Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over how to transform functions graphically. Before we get started, let's take a look at the formula that's going to be guiding our graphing process, which is known as the transformational form for functions. Okay, so the transformational form for functions is given by y equals plus or minus a function of plus or minus 1 over b, x plus or minus h plus or minus k. Now the a, b, h, and k components are the values that change the look of the graph. A and b can be thought of as the vertical and horizontal dilators and reflectors. H and k can be thought of as the shifters. So h shifts horizontally and k shifts vertically. If you take a look at the details for a, the sign of a results in a vertical reflection across the x-axis. If a is negative, you have a reflection. If it's positive, you do not. The absolute value of a indicates the presence or absence of a dilation in the vertical direction. If a is between 0 and 1, the absolute value of a, that is, you have a vertical compression in the direction of the y-axis. If the absolute value of a is greater than 1, then you have a vertical stretch. The same thing applies with the b value, but it occurs in the horizontal direction. Now, one thing you want to keep in mind is that for the b, you're looking at the reciprocal of the coefficient of x. Okay? And then when you have x minus h, you shift to the right. X plus h, you shift to the left. If k is positive, you shift up. If it's negative, you go down. Alright, let's take a look at questions 1 and 2. The first one, let's write down the instructions. We are to describe the reflections, dilations, and shifts, then sketch the graph. Okay, sketch the graph. Alright, for number 1, let's say we have the function y equals negative 2 times 1/3 x minus 2 raised to the third power plus 1. Okay, so what we're going to do first is we're going to compare this function that we have with the transformational form. Basically, set it up in a way where we can determine what the a, b, h, and k values are, and then we can know the exact transformations to apply. Okay, so we have y equals negative 2, 1 over 3, x minus 2 raised to the third power plus 1. Alright, so let me put the transformational form function on the top here. So we have y equals a times the function is going to be the cubic function 1 over b x minus h cube plus k. Alright, so you can clearly see what a is, what b is, what h is, and what k is. Alright, so let's start by indicating what family this function belongs to. Since it's raised to the third power, it belongs to the cubic family. Now let's take a look at the reflections. So for reflections, to determine what the reflections are, we're going to be looking at the signs of a and b. Signs of a and b. If any of these two variables are negative, it results in a reflection either vertically or horizontally. Now, if you take a look at this problem we have, we notice a is negative. So what does that mean? The negativity of a means that we're going to reflect vertically across the x-axis Why? Since a is less than 0. That results in a vertical reflection as indicated here. Okay? Alright, so for horizontal reflections, there are none since B is positive, so we just have only one reflection. That's that for the reflection story. Now let's take a look at the um, dilations. So for dilations, we're looking at the size, okay, the size of the absolute value of A and B. We don't care about the sign anymore, just the size. Alrighty. Now, let's start with the vertical direction. Okay, let's pull up our function into view. Vertical shift, we're looking at the absolute value of A again. It's bigger than 1, so that means that we're going to stretch the graph vertically. Okay, so we're going to stretch vertically by a factor of 2. Why? Since the absolute value of A is equal to 2 of value that is greater than 1. Okay, so if it's greater than 1, you have a stretch. If it's between 0 and 1, the absolute value that is, you have a compression. How about horizontally? B is 3. Okay, the absolute value of B, sorry, is 3. So that means we're going to stretch the graph horizontally by a factor of what? By a factor of 3. Why? Since the B value, absolute value of B value is equal to 3, a numerical value that is greater than 1. Okay? So that's that for our reflections and dilations. The last thing we're going to look at are our non-rigid transformations, known as the shifts or translations. Alright, so for the shifts, we're going to be looking at our at the size and sign of H and K. Okay, so you look at the size and sign of H and K. So that's that. Alright, so let's look at our shifts. So next, x we have is x minus 2. So that means we're going to shift 2 units since it's minus, and next to x is going to be the opposite direction. Shift 2 units to the right since since h is equal to 2. And then for the k component, you can see that k is equal to positive 1. So what does that mean? That means we're going to shift 1 unit in the upwards direction. Okay, shift 1 units up since the k value is equal to 1. Alright, so we're ready to go ahead and sketch the curve. Let's set up our coordinate system first. Alright, so we're going to start off by sketching the graph of the parent function, and then we'll go from there. Okay, so to help us to generate the graph of the parent function, what we're going to do is create a table of guiding points. Just 3 points will suffice, okay, just to guide our construction process. So we're going to call this guiding points. X and y equals x to the third. Okay, so we have -1, 0, and 1 since we have an odd function. If you plug -1 into x cubed, you get -1. 0 into x cubed, you get 0. 1 into x cubed, you get 1. Alright, so let's go ahead and plot those points. So 0 0, I mean 0 0, origin, 1 1, negative 1, negative 1. Alright, so we want to sketch the graph. So this is basically what the parent trig function, the parent cubic function looks like. Concave down in that direction. Alright, so the intermediate graphs will be dotted since it's not the final answer. Okay, and then we are going to label them as we go. So this is this graph that we have right here is y equals x to the third, the parent cubic function. Now let's start with our transformation. We're going to do the dilations and reflections first. Let's start with the dilation. So, or we can reflect first. So for reflect, the point on 0 stays at 0. This point gets reflected vertically across the x-axis, so it ends up down here, and this point gets reflected across the x-axis, ends up here. So there goes our reflected cubic function. Like that. Is now decreasing. The original one was increasing, but this is now decreasing. Like that. And then this is y equals negative x to the third. Okay, y equals negative x to the third. So this is the reflected one is negative x to the third. Okay, now let's carry out our dilations next. Let's do the vertical stretch first. We're going to stretch it vertically by a factor of 2. So one thing you want to keep in mind when stretching a function is that you start stretching from the axis that you're stretching in the direction perpendicular to. Okay, so we're stretching by a factor of 2. Some students will start from the points and count 1, 2. That's not how you do it. So if you want to stretch by a factor of 2 vertically, what you're stretching is the distance of that point from the axis that you're perpendicular to. So your 1 unit from the x-axis here, if you stretch by a factor of 2, it means that this point will become 2 units out. Alright, let me change the color there. So stretching it, this goes up to 2 units. 0, if you stretch 0 by a factor of 2, it stays the same. And then this one is 1 unit down. If you stretch it by a factor of 2, it becomes 2 units down. So this is the resulting graph when you stretch the function by a factor of 2 vertically. Okay? Alright, now how about the horizontal stretch? Same principle applies. When you're stretching horizontally, you're going to be tripling or multiplying the distance from the y-axis by that factor that you're stretching by. Okay, so we're stretching by a factor of 3 in a horizontal direction. So we're going to continue from where we stopped. Right now we are at this function right here, y equals, this one has been reflected and dilated. Let me write it. So the red one is going to be y equals negative, so it's stretched by a factor of 2 to x to the third. Alright, now if we want to dilate by a factor of 3 in the horizontal direction, let me use my purple tip. So we have, starting from the red one, okay? So this is 1 unit from the y-axis, so we're going to triple that. 1, 2, 3. That's where it ends. And then this point 0, if you triple that, is still 0. And then the horizontal distance from the y-axis to the red point on the red graph is 1 unit. If you triple that, you go out 1, 2. That's triple the distance. Okay? So when we connect the dots, we're going to see the resulting graph after the reflection and the dilations vertically and horizontally. Alright, so let's go ahead and connect the dots. So it'll look something like this. Still going to be dotted since we haven't yet generated the final graph. So to the center, through the center, and curves downwards like that. And this one goes upward like that. Okay, let me fix this point right here. So we have a point right here. So it just goes like that. Okay, so this graph that we just created, this graph is y equals -2 parentheses, the horizontal stretch by a factor of 3 is represented by 1/3 x to the third. Okay, so this 1/3 means horizontal dilation by a factor of 3. Alright, so last but not the least, we're going to shift now. Okay, we're going to shift our graph 1 unit up and 2 units to the right. So if you take the center, 1 unit up, 2 units to the right, 1, 2, that takes you right here. And then this point, 1 unit up, 2 units to the right, 1, 2, that takes you, so 1 unit up, 2 units to the right, takes you right here. And then this point right here, 1 unit up, 2 units to the right, 1, 2, that takes you right here. Okay, so this is what the final answer looks like. It's going to be, we're going to make it solid. So we have the cubic. It looks something like this, going down, and then the other one, the other part, go through that, heading in the upwards direction. Okay, so this is the final answer. Let's write down what the equation is. Y equals -2. So the negative means you reflect vertically. 2, you stretch by a factor of 2 vertically, times 1/3. This means you stretch by a factor of 3 horizontally, times x -2. -2 means you shift to the right 2 units. And it's a cubic function, plus 1, which means you shift up 1 unit. And ladies and gentlemen, this is your final graph. Okay? Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of transformation of functions, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips, tutorials, and support resources can be found on mathgotserved.com. Go ahead and check it out. Thanks again for watching, and have a wonderful day. Goodbye.